Alright, boys and girls, welcome to our very first video lesson in Chapter 9. Our lesson where we will embark upon our quest to discovery, the interesting saga of conic sections. Alright, here we go. Okay, the first conic section is circles. I promise you we will derive the formula for a circle in class, but our first conic section is a circle. A circle, as you know, is the locus of all points that are equidistant to a given point. We call our given point the center of the circle. We're going to label that HK. And our circle now is the set of all points that are equidistant to that given point. Well, any point on our circle, x comma y, is going to fit into this equation right here where HK is the vertex of our, is the center point of our circle. And of course, R is our radius. Let's try one. So looking at this equation right now, let's figure out where the vertex is and how big the radius is. Well, I know. In this case, our h is 0 because that's x minus 0 squared. Our k is negative 2 because that's y minus negative 2 squared. And r is equal to 2 because r squared is equal to 4. That's right here. So now our vertex is at 0 comma negative 2. And our radius is 2. If I were to plot this circle, so here's our graph. It's going to have a center point at 0 comma neg 2, which is right here, and a radius now of 2. So it's actually going to go through the origin, and there is our circle. Alright, let's try another one. This time we're given the equation. Let's come up with the center point and the radius. But in this case right now, we have a circle that's not in HK form. So I'm going to have to complete the squares a couple times. So first thing I'm going to do is I'm going to move everything over to one side. Or I'm going to move the x over to one side. So I'm going to add 14x to both sides. And now I'm going to write this as x squared plus 14x plus blank plus y squared plus 6y plus double blank is equal to, and I'm going to write this right below here so I have room here, negative 50 plus blank plus double blank. And now you remember how to complete the square, and we'll do some of these in class as well. But in order to complete the square with the x's, I'm going to take my b term, which is 14, cut that in half, and I'm going to square it. Half of 14 is 7. 7 squared is 49. So I'm going to put a 49 in there, which means I'm going to put a 49 in here too as well. Now I'm not going to do the same thing with my y's. My b term is 6. Half of 6 is 3. I'm going to square 3 and get 9. So I'm going to add 9 right here, which means I got to add 9 to the other side as well. So now it looks like in purple here, I got an x expression. I have a y expression, and that's equal to negative 50 plus 49 plus 9. So I know now that x squared plus 14x plus 49 is x plus 7 squared. So I'm going to write that as x plus 7 squared. My y squared plus 6y plus 9, this part right here is going to become y plus 3 squared. And that equals negative 50 plus 49 is neg 1. Neg 1 plus 9 is 8. So it looks like now I have a center point. My h is neg 7. My k is neg 3. And my radius is equal to the square root of 8, which of course we know is 2 root 2. Okay, we're going to talk about our second type of conic section now, the parabola. A parabola is a locus of all points, so it's a set of points that's equidistant from both a point, which we call the focus, so that's going to be this point right here, the focus, and a line, that's this green line right here, which we call the directrix. So the parabola is the set of all points that's equidistant from both a line and a point. The line being the directrix, and the point being the focus. The easiest point to find on the parabola is going to be the vertex, which is halfway in between the focus and the directrix. So this point right here is my vertex, and I of course now know that this distance is equal to this distance, okay, and that distance we're going to eventually call P. All right, and then every other point on the parabola, so like if we just look at this one right here, this point right here, this distance is equal to this distance. If I choose a point right here, this distance is equal to this distance. If I choose a point right here, this distance is equal to this distance. If I choose a point way up here, this distance is equal to this distance. So every point on my parabola is equidistant, the same distance away from my focus and my directrix. Okay, the equation of a parabola, if it's vertical, is going to be y is equal to a times x minus h squared plus k, where of course hk is my vertex, and we'll prove this in class. And a is always going to equal 1 over 4p, where p is this distance, once again, right here between the vertex and the directrix, or the vertex and the focus. A couple more words you need to know. This purple line right here, this is called the axis of symmetry. This is the axis of symmetry. It is a line that's perpendicular to the directrix that passes through both the vertex and the focus. And we also have a line right here, okay, called the latus rectum. The latus rectum is a line that passes from through the focus, so I'll draw that here in blue, my latus rectum. The latus rectum is a line that passes through the focus from edge to edge of the parabola. And the latus rectum is always equal to the length of 4p or a. Okay, let's try one here. Let's name all the stuff for the parabola. I'm given now that my focus is at neg 3, 2, and I have a directrix at y equals neg 6. Okay, so let's put in some of these points. My focus is at neg 3, neg 2, so my focus is right here. Hopefully you can see that. There's my focus. My directrix is at y equals negative 6, so it's a horizontal line at negative 6. Okay, I can now see that my vertex is going to be halfway in between my directrix and my focus, so it's going to be right here at neg 3, 4. Neg 3, neg 4, I should say. Neg 3, neg 4. And my parabola is now going to go up something like this on both sides. Okay. I can also see that my P has a length of 2, because it's the distance away from both my vertex to the directrix and my vertex to the focus. So my P is equal to 2. I'm just going to write that somewhere down here. P is equal to 2. I know my axis of symmetry. I'll draw that in red, purple. Here's my axis of symmetry. It's a vertical line going through the focus and the vertex, so it's x equals neg 3. Okay, if p is 2, the length of my latus rectum now is 4p, which is 8. So my latus rectum is this length right here, and that's a total length of 8, so I was actually much wider. Okay, and now my equation I know is going to be y equals a times x minus h squared plus k, because it's a vertical parabola. Okay, it's an up-down parabola. I can now put in my h. My h, of course, is neg 3, so I'm going to put in x plus 3 right here. My k is neg 4, so that's minus 4. And now I just need to figure out my a. Well, remember now, a is equal to 1 over 4p. P was 2, so A is equal to 1 over 4 times 2, which is 8, so A is equal to 1/8. So my equation is y is equal to 1/8 x plus 3 squared minus 4. This guy right here, we're going to look for the equation, and we're going to try to draw the picture of the parabola that has a vertex at 2, 2. So that's right here. There's our vertex. It has a focus at 8, 2, so that's way over here. There's this focus. I can already see now that this parabola is horizontal and it opens to the right. Okay, this length right here in green is going to be my P. It's between the vertex and the focus, so P is equal to, it looks like 6. Okay, my directrix then is going to be 6 places over here to the left, so 6 places from here, so I need to go 6 places this way, over here, so 6 places to the left to get to my directrix. My directrix is going to be at -4. Right here. So my directrix is x equals -4. My axis of symmetry is going to be this line in purple right here. Okay, so my axis of symmetry is y equals 2. The length of my lattice rectum is going to be 4p. Well, p is 6, so this is going to have a length of 24. That's positive 24. Which means it goes 12 to either side of my vertex. So my parabola is going to go way out here, 12 places each way. So way down here and way up here. So now I have a parabola that looks like this. Okay, and the equation for my parabola now, of course, it's the reverse because it is a horizontal parabola. So it's x equals a times y minus k squared plus h. I can input my value of h and k. H we decided was 2. K we decided was 2, so this is going to be y minus 2. A, of course, is equal to 1 over 4p. P was 6, so A is equal to 1 over 4p. P is 6. A equals 1 over 4 times 6, which is 24. So A is equal to 124, and it's positive because it opens to the right. So x is equal to 1/24, y minus 2 squared, plus 2. Okay, let's do one more in our continuing saga on parabolas. We are looking at a graph now. I can see my vertex is going to be at 2, 1. I'll write that in a minute. My focus is going to be somewhere in this range. Not sure where it is yet. Not sure where it is. My directrix is going to be somewhere over here. It's going to be a vertical line. Not sure where it is yet. I need to figure out my P. My axis of symmetry is actually, I know what that is. That's this line right here. It's the horizontal line that goes through the vertex, so it's going to be y equals 2. And we're going to have to figure out what our P is to figure out some this other stuff. So let me write in what I know right now. My vertex is at 1, 2. My axis of symmetry is y equals 2. It's the horizontal line right here in purple. Okay. And now to figure out my equation, I know I'm going to have an equation x is equal to a times y minus k squared plus h. Well, I know my vertex is at 1, 2, so k is 2, so x equals, I just put the 2 right here over the k, and h is 1. And now what I'm going to do in order to solve for a, I'm going to take another point, and I'm going to choose this point right here because I can see what it is. I'm going to take this point right here, which is at 3, 1, and I'm going to plug it into my equation and solve for a. So I'm going to write here now, x is 3 is equal to a, that's what I'm solving for, 1 minus 2 squared plus 1. So it looks like now 3 is equal to 1 minus 2 is neg 1. Neg 1 squared is 1, so I have 1a plus 1. It looks like a, if I subtract 1 from both sides, a is equal to 2. Now I can use that a is equal to 2 to come up with my 4p. But first of all, let's just write our equation, because it did ask for that. My equation, I'll write that up here in purple. X is equal to 2 times y minus 2 squared plus 1. Okay? But now I can use my a is 2 to figure out my 4p. I know that p is equal to 1 over 4a. So if a is 2, p is equal to 1/8. So p is very, very close. So in other words now, I'll do this the best I can, but p is 1/8 away, or my focus is 1/8 of away from my vertex, and my directrix is 1/8 of away from my vertex. So they're very, very close to the vertex. So our directrix is at x equals 1 7/8, because that's 1/8 away from 2. And our focus is at 1 1/8, comma 2, because that's 1/8 away from 1, 2. So there we go. My latus rectum has a length of 1/4, because it's 1/2, because it's 4p. All right. Have a great day, folks. We'll see you soon.